So our last lesson in the logarithm and exponential chapter is us doing more regression work. So remember we did linear regression and power regression, quadratic regression. Now we have to talk about logarithmic regression, exponential regression, and then there's a new one that we looked at yesterday on that bear question called logistic growth. So kids sometimes have a difficult time with the difference between logistic growth and a logarithmic regression. So that's one of the things we have to kind of get around today. And a major component of this lesson that would make it very difficult would be if I didn't tell you what type of regression to use on the test, but turns out I am going to tell you what type of regression to use on the test. So since that eliminates a big chunk of the difficulty, this lesson is going to be a lot shorter than it used to be. So there's going to be parts of the lesson and parts of the homework that you guys you get to ignore. It's where it asks you about running any sort of tests to determine which one is the best regression. So that's the good news. All right, first we are going to be looking at the shape of the scatter plot. So if you were in a situation on your homework or in the future where I didn't tell you what kind of regression, the easiest way for you guys to make at least an educated guess is to look at the scatter plot of the data. So if your data is exponentially growing or it looks to be exponentially decaying, you're going to use what's called exponential regression. And then if it takes on the shape of a logarithm, this kind of logarithm is kind of hard for kids to understand, but the idea is you're going to see almost a vertical asymptote approaching. The issue with data, because it starts and stops, it's not like the entire curve. So some kids would argue like, oh, it doesn't look like there's a vertical asymptote. So we have to kind of run some calculator tests on it in the normal world, but in PreCalc, I'm just going to tell you. So could you please get your data for this first example entered into list 1 and list 2? Except we know we don't use calendar years in data, so we're going to call 1950 year 0. So 1960 is 10, this is 20, this is 30, 40, and 50. And I'm going to pause my video, and the watcher is also going to pause their video and enter the data. So and I have a lot of data here because I have all the data for the rest of the worksheet, but list 1 and list 2 is where I put the data for our table. So normally, I shouldn't tell you what kind of regression to use, which means you'd either have to do what's called testing, which is no fun, or at the very least look at a scatter plot. So go to y equals, clear out anything that already exists from a previous question, and then you need to adjust your plots so that you have a plot turned on, and it's going to graph what you want it to graph. So like for instance, I already know because I set it up during first hour that my first plot, if I go to stat plot, or not, is graphing list 1 and list 2 as a scatter plot, because I already did this an hour ago. But you guys might have to adjust the way your plot is plotting. And once you have that adjusted, and once you have it turned on, you can just hit zoom 9, zoom stat, and you should see a scatter plot. So even though they kind of spilled the beans later on the worksheet and said, by the way, this is exponential regression, you guys should be able to look at that curve and deduce that, yeah, it's an exponential growth function. So now that we're pretty sure it's exponential growth, we're going to call up the regression command on our calculator. So back to the stat menu. This time you're going to calculate something, so go over to calculate. And you have to kind of, there's a lot of regression, so be careful you're choosing the right one. We're looking for exponential regression. So it's down here at 0. EXPReg. So on our newer calculators, it's going to ask you 4,000 questions before it does anything. So where's your data? Now my data is not in list 5 and list 6, so I need to change this. I put my data in list 1 and list 2. I don't have any frequency lists. And I always store my, I just get in the habit of storing my function into y1 just in case I need it later. So store the regression equation in y1 by going to varies, y varies, and function. Thank you. And then once that's all set up, command it to calculate, and it's going to spit out some information to you. There we go. So if you don't have r and r squared, that means your diagnostics are not turned on. Remember, anytime your calculator gets reset, the diagnostics get turned off. So who remembers where I can go to turn them back on? Always go to the catalog, which is second 0. And then you got to scroll down to diagnostics on and command it twice. But for now, just trust me that these are this is the correlation coefficient. So r is 0.999. That's a pretty good fit. So our guess at exponential regression was a good one. But this information right here, this is the information that you're going to put into the exponential formula. So you're going to write down y, and you're going to have to round, obviously, because no one wants to write that many decimal points. You're going to write y equals 1812.01 times 1.035, let's round it, to the x power. So on the next slide is where you wrote that down. 1812, was it 0.01? Yeah. So I'm going to back up and answer the other question in a minute. It originally asked me about what is the growth rate. So B represents the base, but if you guys think back to the formula for this, it's A times either 1 plus or minus the growth rate to the x or to the t power. So if you have 1.035 as your base, the growth rate is how far away from 100% it is. So think about subtracting that 100%. Your growth rate is the decimal 0.035, which we know is the percentage, 3.5%. So it's the same exponential growth function that we've been working with, but it's one that was derived through regression off of some data points. And then there's a follow-up question. It says, estimate the 2020 GDP. So remember in our data, we let time start at 1950. So if time starts in 1950, this would be 70 years later. So the safest way to answer this question, I usually put my calculator's table in ask mode, and then I just type x equals 70. You could scroll down to 70, but that sounds like a tedious process. Or you could trace on your graph. You're going to have to extend your window, though, if you do that, because your window's not going big enough. So I think the easiest way to get this question answered is to put your calculator in ask mode for the independent variable. And I got like 20136.55. No, I don't. I got something else because that was my rounded decimal. 19,000 something? I don't know, something around there. I think when I answered this, I plugged into the truncated formula, which I know doesn't sound like a big deal, but it really did affect the answer. It was like 1,000 off or something. Someone rattle off an answer to me. If you're on your table, I suggest you highlight the number that you're looking at because there's probably a decimal, some digits you're not seeing. Look at you all just staring at me thinking I did this question. I didn't. Is it 19? One more time. Is there any decimal points on it? Or? Okay. Yeah? Okay, sounds good. So in my key, because I plugged in the number 70 into my truncated function, I got like 20,136. Like, that's really far off. So be forewarned, there's going to be times in our pre-calc life coming up where you need a super accurate answer and you can't afford truncation. This really isn't one of those questions, but there's one coming up where we can't afford to truncate, so you have to use the most accurate answer as possible. So I steal yours because yours is way more accurate. All right, so that was super fun. We're going to see a question coming up at the end of the notes where instead of an exponential growth or an exponential decay, the graph looks like a logarithm. So before we move on to the weird thing, I want to talk to you about in the regression options. Whoops, not that. Stat. In the regression options, we saw exponential regression. That was down at number 0. I need you to tell me where I can find what's called logarithmic regression. And I'll give you a hint. Whoops, hold on. It's on my screen somewhere. Which one represents logarithmic regression? Oh, I was trying to trick you and I couldn't even trick you. Yes, it is the ln one. Yes, it's the natural logarithm of x. That's the logarithmic regression. Because a lot of kids look at, do you see B down there? It says logistic. And since we all kind of read shorthand now, you see log and you're like, log. Well, it's not log. It's logistic growth. That is a different type of function that you'd be creating. The logistic growth, the one that's down here at number B or letter B, That has to do with, remember our bears question yesterday about like logistically there's only so many bears that can live in the habitat? That's a logistic growth question, very different from a logarithmic regression question. So if you ever are asked to do a logarithmic one, you're looking at number 9, which is the natural log regression. So be careful on that. All right, back to our paper. If you flip over to 13b, they want to talk to you about logistic growth. So we kind of discovered one yesterday on one of our homework papers. It was the bear question, and it talked about for species in an environment, there's what's called a carrying capacity to the function. So it creates what essentially is a horizontal asymptote, and the function kind of tops out and doesn't go beyond that. And if you think about it in terms of real life, you know, if you have a population of animal that's feeding off the environment, they can't continue on without bound forever. Eventually resources will die off, nature will take its course, there won't be as many things born, more will die because they're starving. The population will not continue to grow without bound in an enclosed animal habitat. So you'll see a lot of these questions are like, there's deer in a park, there's moose in a forest preserve, there's bear in a park. I don't have a lot of examples for this, and they're all revolving around animals in a park for some reason. So the good news is on your test, there won't be any ifs, ands, or buts about it. Like, I'll say, there's deer in a park. Here's your formula. It's a logistic growth. Do some stuff. So it's very clear cut what you're supposed to be doing. You guys will never have to hand derive this formula for me, but it is you are capable of finding a formula through regression on your calculator. So if we jump to this question, which represents the number of mice living in a certain habitat. So right away, if it's a nature problem, if I didn't know, I'd probably go with logistic growth, just because it's one of those nature problems. But they do tell you in a minute to find the logistic function. So first thing I need you to do is get your data entered into 2 lists. Because I already have my data entered, mine are going to be in list 3 and list 4, but you can put your data wherever you want. Video's getting paused. My watcher has to pause as well. So once your data is entered into 2 lists, mine are in list 3 and list 4. If I wasn't told to do logistic growth and I wasn't sure, or if I had to create a scatter plot, I would go and adjust my scatter plot. So in your scatter plots, I've already designed mine to graph 3 and 4 if I turn on plot 2. So what I'm going to do is turn off plot 1 and turn on plot 2, but you guys can just adjust whatever plot you want. The other thing you're going to need to do is delete the function from the previous question, because that's going to mess up your graph otherwise. So once you have the appropriate things being plotted, you're going to have to zoom stat one more time so it could readjust the window. And that's what you're going to see when it creates a logistic growth. Now, first glance, you might say, that looks a lot like a logarithm, because you see like this weird little part at the top that kind of flattens out. A logarithm does that too, but a logarithm, you'll see the beginnings at least of a vertical asymptote. This one doesn't have that. Plus, it's a nature question. Plus, if you read on, they went ahead and told you to do logistic. So we are going to do a logistic growth function. They haven't given it to us. On the test, it'll be given to you. On this problem, we have to calculate it through regression. So stat, and then you're going to choose, this time it's a logistic regression. So go down to letter B. And make sure your data's in the right spot. Mine's in 3 and 4. And I always like to store my function just in case I need it later. Alright, now this one looks messy, because your calculator types horizontally. So you're going to see like a slew of parentheses because that whole big thing is the denominator. So when you go to write down this function, you're going to write down y equals c is the constant that's at the top. So just go ahead and round that off to 10 because it's 10.00. And then you divide by 1 plus a, which is 2.36 times e to the negative bx power. So it's going to be the negative, go ahead and round to 0.5 times x power. That's the function. Gross. Now, on the test, I went ahead and gave you the function, so you don't have to go through the regression step. but you do have to know how to type this in the calculator if it's already given to you. Make sure that if you're typing it in by hand, that when you go to type back in your calculator, you use parentheses around that gigantic denominator, otherwise it's not going to graph properly. So either way, that's our function, and then it says, find the value of the model at x equals 20. So you either need to plug in 20, you either need to trace to 20, or you need to go to your calculator and plug in 20 that way. Either way, you should get really stinking close to 10. I didn't write any of that down. So I'm just going to say about 10. So then the question is, make a conjecture about why the logistic model may fit the data. So without really looking at the scatter plot, there's a reason that's overarching on this question that should have told me it's a logistic growth question, and the reason is it's a nature problem. Anytime it's a nature problem having to do with the population of something, it's logistic growth. But like I said, on your test, you guys don't have to do any guessing and checking. The reason they brought up that question is because this hot mess. So this is called testing your data, and this is the stuff that we are skipping. It's a hoot, let me tell you. So you take your variables, your x and y variables, and you create extra tables, or sorry, extra lists, and you compare like the square root, the natural log, you come up with all these weird functions, and you try to figure out which combination is the most linear. Super fun. We don't have to do it. So the good news is that just cut out like 25 minutes of your life that you won't really need this for. If for some reason you move on and you're going to become like, if you're going to go into analytics, you'll discuss this at an upcoming calculus class. But for a pre-calc kid, you can move on in life without knowing how this works out, okay? So here's what's going to happen on your homework. Instead of having you test for the data, at the very worst, what I would make you do is look at the scatter plot and go, I think that looks like a logarithm. And that would be the way you guys are going to test it. We're not going to do any of the natural log x square root of y thing. So anytime the linear test shows up in any of your homework questions, just ignore it. All right, so this next one, the very last one on your notes, example 2, let's get this data entered into our calculator. My data is going to go in a weird spot, so I'm going in list 5 and list 6. So once your data is entered in 2 lists, worst case scenario is I never told you what regression to do. So if that's what happened, then you'd go look at your data on the scatter plot. So I need to clear out my old function from the last question. I've already set up scatter plot 3 to graph the list that I want to graph, but you guys adjust whatever you have. And then of course you got to zoom stat one more time. And you're going to see that. So this is where kids are like, wait, that looks like the mouse problem that we just looked at. There's some key differences. So the first difference is this is not a nature problem. If you read on the context of the question, it says it's a computer virus that is measured over time. How many machines will be infected over time. So, like, I know one could argue, like, it's kind of like a nature problem, but, like, not really. You could argue that there's only so many machines in the world. I agree with that. But here's some things that I notice on the, let's just look at the shape. It's not easy to see, but there is kind of like an approach to a vertical asymptote on the left side. It stops because there's only so many data points, but it does kind of swing down quite a bit. The other thing I notice is the top of the function is not obviously flattening out to a horizontal asymptote. It's just decreasing the rate at which it's increasing at. So that kind of leads me to believe that this is a logarithm function. So not logistic growth, but a logarithm function. So here's how we're going to know if we're right. We're going to try it, and if the regression number is bad, then we're going to try something else. So stat, calc, and which one is logarithm again? Be careful. It's number 9, the natural logarithm regression. So make sure your data is coming from the right spot. Mine's list 5 and 6. And I don't think you need to store the function this time. Oh wait, do we? I think it moves on to the next page. How terrible. You know what? You might want to store the function. You don't have to, though. The question that they want you to answer at the end of it, if you use the truncated function and just manually plug it in, it's fine. So I'm going to go ahead and just calculate it. Yeah, that was pretty good. 0.99999. So that's a really good fit for our data. Now we have, make sure your numbers are going in the right spot. The function says a plus b times natural log of x. So on our function, we're going to write down y equals a, so 614 point, whatever, I'm going to round to tenths place, plus 217.4 times the natural log of x. So there's your function. And then if you keep looking onto worksheet 14 now, it kind of laps over to number 14. They went through that horrible testing thing, the thing that we're totally skipping. So this part here says step 2, test. So just write yourself a big note that this is the stuff that we cut out of the curriculum. We are skipping this process. If you're really, really curious, you can go look up my old video from last year where we actually did this problem. Fun times. Otherwise, skip down to the calculate step 3. Oh, we wrote down our function. I just forgot to write it down here. It was 614.4 plus 217.4 natural log x. Oops, that's ugly. And then they're encouraging you, they actually truncated more than we did. They went to the whole number. They're encouraging you just to plug in the number 9 into your function, and it becomes about 1091, depending on where you round and truncate. So that's how many, what was it, computers were infected with a virus, I guess? I don't know. That problem was boring to me. I wasn't really interested in it. All right, so that's an example of a logarithmic regression. So the most important thing I think for you guys is, yes, I will be telling you on your test which one to use. You just got to make sure you choose the right command on your calculator. So here's what's going on now. As we look through worksheet 14 and 15, those are your assigned questions, but the assignment actually starts on, where are we at? Worksheet 14B. So it's a little confusing on the homework checklist because it kind of looks like those question numbers are just on worksheet 15, but it's actually all of it. So starting on worksheet 14B, and then you go to 15A, and then you go to 15B. Your final assignment is, and I suggest you circle them, numbers 2 and 3 and 4 and 5 and 9. So since you guys have plenty of time to get going on your homework, I'll do you one better. I'll go ahead and tell you which type of regression you're supposed to use on each question, so you don't even have to tinker around with scatter plots. How's that for nice today? All right. So if you look at, so I'm looking at worksheet 14B. First one assigned to you is number 2. So there's a question on number 2 where it's like, make the scatter plot, which, you know, you can just fudge in a little scatter plot when you look at it. You don't have to do part B where it says do the linear test and which one. So scribble that part out. And I'm just going to tell you guys, you should do logarithmic regression. So that means, what, it was number 9, wasn't it? Is it number 9? It says lnx. All right, number 3. They kind of spilled the beans there. If you look ahead to part B for number 3, it says find the logistic model. So, spoiler alert, it's logistic growth. Which is, I call it number B, but you know what I'm saying. Logistic. And then 2, 3, 4. Now number 4, I think you got to find worksheet 15. After you look at the scatter plot, it's a lot like our question on our notes. We have to adjust the calendar years to start at, you know, year whatever. So it looks exponential to me. So it's exponential. I forgot what number it is, but it's EXP regression. And number 5, oops. Okay, 5, it flat out tells you it's a logistic model, so that's not really a mystery. So logistic growth. And then final one is number 9. on worksheet 15B. Well, it's about fish, so it's got to be logistic. So, there's a lot of logistic growths on there, sorry. They're a little annoying to write down, but you'll be fine. Now that you don't have to do any sort of guessing and checking as far as which regression to do, I think this should be a pretty quick assignment for you guys. So, you got time now. I want you to finish it. Your homework check is officially due on Friday. We'll let you go to Friday because of the traumatic weekend you all had where you couldn't do my homework. If you never looked at 3.4's homework, the bookwork that you're supposed to do over Thanksgiving weekend, I might suggest you go back and do it. Those are the kind of questions that you need a lot of practice doing, so that way you can execute them well on your test. The new stuff, the stuff we just learned, maybe take a look at your purple review and decide, like, you know, how much practice do you need on logistic growth and logarithmic growth, and how good are you using your calculator? Because you might decide if you have to sacrifice some homework time from you guys. I know some of you are not in a position to finish your homework tonight, but if you need to sacrifice and say, like, oh, I'm willing to do this much time, just do things that you need practice with, please. That would be great.